little bit deeper to look at some of the parts of an experiment so you can understand what are the key components. We're not going to be actually designing experiments in this part of the lesson. We're just looking at a basic overview. So first of all, what are the parts of an experiment? Well, you need someone to experiment on. Those are your experimental units or your subjects. When your units are humans, they're subjects. And so when I'm trying something different in my curriculum, I am experimenting on subjects, my students. The explanatory variable is a thing that you're hoping is going to make a difference, whether it's some new way you're grading for me or a different type of hormone that you could be taking or some medication. The response variable is what you're going to measure and say, oh good, look at the effect it had, whether it is lower risk of heart attack or better grades on DCAs or a higher SAT scores. Anything can be the response variable, whatever effect you're looking for. Now, the treatments are when you use whatever you think is the explanation. For example, with the hormones, we could do placebo or a certain level of hormone or another level of hormone. We could have 3 different treatment plans, and that would be part of the experiments. And we look at how the different treatments affect the response variable. So let's go ahead and look at an example. Here, Career Start, they're trying to link knowledge to careers, and they're developing something for schools, and they're hoping to have a positive impact on the students. And not only that, they're a business. They would like the schools to want their product. So they recruited 14 middle schools in Forsyth County, North Carolina. The schools are the experimental units. So they're not subjects because they're not humans. They're humans in the schools, but the units are actually the schools. So they're looking at the response across the school. And from those 14, they randomly selected 7 to get Career Start plus their normal curriculum, and the other 7 just used the normal curriculum. The explanatory variable, again, the thing that's supposed to explain it all, is Career Start. It's supposed to be amazing. So the treatments are either normal curriculum plus Career Start or just the normal curriculum. So researchers collected data on attendance, behavior, test scores, levels of engagement, and graduation rates. All of these are response variables. So if Career Start's lucky, they're going to have a positive impact on these response variables, thus inducing schools to want their product. So now let's go ahead and look at a graphical view of an experiment. You always start with your individuals. Who's in your experiment? All right. How are we going to determine what treatment they get? Well, we're always going to use random assignment. If you recall from the random rectangles activity, we found out that when we had randomness in our sampling, we were closer to the actual value than when we used judgment. So we're not going to try and use judgment to assign these schools. We're just going to randomly separate them, okay? And some are going to get we're trying to figure out the impact of this explanatory variable, Career Start. So one treatment will include Career Start, and the second treatment won't. And then we're going to measure, here's our response variables, attendance, behavior, test scores, engagement, and graduation rates. Now, there are 4 principles of experimental design. Control, and we control for factors by assigning different factor levels. We want to randomize so that we can kind of even out the noise from confounding variables so that we don't accidentally confuse the effect of a confounding variable for the effect of a treatment. And we need to replicate. It's important to repeat experiments. You want to make sure, first of all, that your sample size is large enough, and you also want to repeat entire experiments. When I was in college, there was this cold fusion fiasco where some students basically, or researchers tried to create fusion in a glass of water at room temperature, and it was a big brouhaha. No one else was able to repeat it, so it's kind of gone by the wayside now. There's one other aspect of experimental design, which we're not going to go into great depth on this lesson, and that's called blocking. So you can create groups for attributes that you cannot assign or control. Things you can't assign or control: age, ethnicity, gender. So what you can do, for example, let's say we did gender. You could have males in one group and females in another, and then test the effects of the curriculum or the hormone treatment. Ethnicity is also interesting because there are different reactions. You know, some ethnicities are more susceptible to some illnesses than others. So you might want to create groups based on age, ethnicity, gender, or some other factor that you really, or attribute, and randomly assign within those groups. So if you had all the females, you would have the females doing each of the treatment levels. And then you would have each of the males doing doing each of the treatment levels, and you would randomly assign that within the block. So control and randomization, we can only compare the groups when all treatments are applied to similar groups. Don't try to match groups. It might be tempting to say, well, okay, I've got this guy over here and he's in his 30s and he's in good condition, and he's not a smoker. So I'll give him the new drug, but I better get another guy that matches him. It's helpful, but it's not good enough because of the confounding variables. Because it's there could be some other factor you just did not see. So our remedy is to rely on chance. Remember, chance improved our results for sampling. It works for experiments too. Finally, what we're looking for is statistical significance. We're hoping to see big enough differences saying, whoa, that's just too big to have been occurred by chance. It really did have an impact. And if our effect is large enough, then we will say that our result is statistically significant.